Hi, Algebra 2. We're going to talk about 4-1, graphing quadratic functions. Just remember a couple of things. Y equals ax squared plus bx plus c is standard form. The x squared is what makes it a quadratic. C is your y-intercept. Because it's quadratic, it's going to give you a parabola. If a is positive, it's going to open like a U. If a is negative, it's going to open like a rainbow. Okay, so example 1 talks about graphing using a table. So I've got my handy dandy graphing calculator, and I'm going to put in my equation 3x squared minus 12x plus 6. And it's always good to graph it and see what it looks like. Okay, now I already know that my y-intercept is 6, so I could mark that point on my graph. Okay, I need to know what that vertex is, so I'm going to do second table, and I'm going to look at those ordered pairs. All right, well, what I really want to look at is my y column. 21, 6, negative 3, negative 6, negative 3. Negative 6 is where it turns and changes direction. So that's my vertex, 2, negative 6. So I'm going to mark that, 2, negative 6. And I'm going to put another one in there, 1, negative 3. And then I just do my mirror images. Okay, and that's going to give me a good parabola. A tall, skinny one. Okay, all right, let's try a couple more. Guided Practice 1A says I need negative 2x squared plus 8x minus 3. Graph, so I know kind of what it looks like. Okay, now I do know already that my y-intercept is at negative 3. Oops, I did that upside down. My y-intercept is at negative 3. It goes upwards. So I'm going to do second table. Okay, negative 3, 3, 5. 2, 5. 2, 5 is my vertex. 1, 3. Okay, and then if I do my mirror images, okay, I've got a pretty good graph. Remember, it was that negative that made it open downwards. All right. All right, guided practice 1B. Y equals 4x squared minus 8x plus 1. So I know plus 1 says, hey, that's my y-intercept. Plus 1. Okay. All right. Okay, so I'm going to go ahead and mark that plus 1, and then I'm going to look at my table. Second table. Okay, where does it repeat? Oh, there it is. 0, 1, 1, negative 3, 2, 1. So it's 0, 1, negative 3. 1, negative 3. Boy, this is a tall, skinny one. Okay, I really want to have one more. Maybe not. 13. Well, that's the very, very top. Okay, so again, it's a tall, skinny one. Okay, all right. So those are the 3 graphs that go with example 1 using a table. Okay, now in example 2, they're talking about your axis of symmetry. okay? Because remember, graphs are symmetrical, okay? What do you need for a good graph? At least the vertex, the y-intercept, its mirror image, and sometimes another point just to give it a good shape. Mine weren't perfect, but I've got those points so I know what it's supposed to be, okay? I'm not going to do the example, but I am going to do the guided practice, and we're going to look at all the different parts. It says find the y-intercept. Well, I know that because I know that the y-intercept, so guided practice 2, y-intercept is 6. That's in my equation. Now the axis of symmetry, because it's y equals negative 5x squared minus 10x plus 6. See, this is B, this is A. So my axis is going to be the opposite of B, which is 10 over 2 times negative 5. So that gives me 10 over negative 10, which is negative 1. Okay, that's my axis of symmetry. That is also the x-coordinate of my vertex. Okay, so when I go to find my vertex, okay, I know it's negative 1 comma something. Okay, and that's when I just go back to my equation and say, okay, negative 5 times negative 1 quantity squared minus 10 times negative 1 plus 6. And you plug that into your calculator and do the math. Okay, second quit, negative 5 times parentheses negative 1 quantity squared minus 10 times negative 1 plus 6, 11. So the y-coordinate of my vertex is 11. So that means if I'm graphing what I know, okay, let's see, what else does it ask for? It says make a table of values including the vertex. Use this information to graph a function. Well, I really probably already have enough, okay, because I know that my y-intercept is 6. Okay, I know that my vertex is negative 1, 11. Okay, I might want one more point, but it might not fit on my graph. Let's look and see. Negative 5x squared minus 10x plus 6 graph. Oops, what did I do wrong? Y equals. Oops, that's a negative. There we go. Okay. All right. Tall, skinny one. But remember, we already knew our vertex was at 11, and this only goes to 10. So I'm going to look at my table. Second table. Okay, there's my vertex right there. See? And then if I do one more point, it's going to be at 1, negative 9. 1, negative 8, negative 9, which means it's going to be, see, sometimes it helps to draw that axis of symmetry, because then it helps you draw that mirror image. See, that mirror image is going to be right here. Okay? Again, another tall, skinny one. Okay? All right, hoping that's helping you some. But my vertex, my axis of symmetry, that formula is just x equals the opposite of b over 2a. This is also the first part of your quadratic formula. All right? Okay. Maximum and minimum values. This is where I'm not going to use my graph. I'm not going to have to graph it, okay? I just have to find that maximum or minimum value, okay? This is example 4. And see, I've got A. A is negative 4. That tells me it's a maximum, because I know my graph is going to open like this, okay? So I am going to have a maximum value. The maximum value is the y-coordinate of my vertex. So I've got to find my axis of symmetry. So x equals negative 12 over 2 times negative 4. All right, I'm going to get out my calculator because it's going to be a decimal. Negative 12 divided by negative 8 equals 1.5. Okay, that's the x-coordinate of my vertex. I've got to find the y-coordinate. So I know that my vertex is 1.5 comma something. I just got to know what that something is. So negative 4 times 1.5 squared plus 12 times 1.5 plus 18. See, I don't want to graph this. The y-intercept is at 18. Okay? All right. Negative 4 times 1.5 squared plus 12 times 1.5 plus 18, 27. All right, that's my vertex, okay? Now, because it's a maximum, that's my highest point. This is my maximum value, okay? Why is that important? Because my domain is all real numbers. My range, since that's a maximum, y is less than or equal to 27, okay? Does that make sense? Y is less than or equal to 27. Now, if I look at guided practice 3, oops, this is example 3. Guided practice 3 says y equals 4x squared minus 24x plus 11. Okay, again, the y-intercept is not going to fit on my MathBits graph. Now, 4 tells me it's a minimum, okay, because it's positive. So I'm going to have a lowest value. Again, I got to find my axis. So x equals the opposite of b over 2 times a, which equals 3. That's the x-coordinate of my vertex. So I got to find the y-coordinate. So I go back 4 times 3 squared minus 24 times 3 plus 11. I get out my handy-dandy calculator. 4 times 3 squared is 9. I know that one. Minus 24 times 3 plus 11 equals negative 25. Okay, again, I wouldn't want to graph that. That's like way off of my MathBits graphs or even the ones I made, okay? But it is my minimum value. Okay, now my domain is still all real numbers, but my range is y is greater than or equal to negative 25. Okay, hope this helps.